Okay, welcome back. And now what we're going to do today is we are going to start talking about non-right triangles and solving situations where we do not have a right triangle. Okay, so in the previous sections we've dealt with trigonometry, dealing with trigonometric functions involving right triangles. Okay, so now what if we don't have a right triangle? What if we have something that's an oblique triangle, which again is a triangle that is not a right triangle. So any triangle that is not a right triangle, we call those oblique triangles. So those could be acute triangles or obtuse triangles. So we call those oblique. So basically, any triangle that is not a right triangle is an oblique triangle. So how do we solve oblique triangles? Well, what we can do is we can use the altitude or height of the triangle. So an altitude, if you recall, maybe you don't remember, is a line. So the altitude of a triangle is a line that goes from one angle and to the opposite side. So it's a line drawn from one angle to the opposite side such that that line segment is perpendicular to the opposite side. That line, in this case, this line segment, let's call this D. Okay, so this line segment CD would be an altitude of this triangle. Okay, now we could use the altitude to form two right triangles, and then we could use trigonometry to see if we can solve for the different parts of the triangle. Okay, we could do that. Or we could use the fact that an angle, the ratio of an angle and the measurement of its opposite side is proportional to the corresponding ratios of the other angles with their corresponding lengths of their opposite sides. But how do we show that? Well, that's what I'm going to show you next. I'm going to derive the formula, in fact, what we're going to call the law of sines. Okay? Now, before we get to that, let me introduce you to the three basic types of situations that we're going to run across when dealing with oblique triangles, okay, that we're going to be going over and solving, okay? And so making sure that we know how to solve, or in other words, approach each one of these situations will be very helpful, okay? So we have angle, side, angle. That means we know two angles and the side between them. We call that angle, side, angle, okay? The other situation is we have angle, angle, side, which means we have two angles. We know two of the angles and then one of the adjacent sides to one of those angles, okay? And then we have side, side, angle, which is we know two sides and then the adjacent angle to one of those sides. Okay, so we call that side, side, angle. So these are the three situations that we're going to talk about, and we're going to do examples of solving using the law of sines. Okay, now, how do we derive the law of sines? Well, let's consider the altitude. We'll call this h. Okay, and let's also consider the lengths of the two right triangles. Okay, so let's use this. Okay, so with h, we have angles A, B, and C, and we have sides C, A, and B. So now, let's also, I'm going to put some tick marks here. Let's see. Okay, so let's see what we can do here. So we've got the altitude h. And now what we want to do is let's use, I'm going to call this, let's call this angle alpha, angle beta, and we'll call this angle gamma. Okay, and so I'm going to use the right triangles to help us with determining this. Okay, or you know what? We could just use A, B, and C. Let's simplify this, because you guys will know. You should know that we could just each vertex we could just represent with the angle A. So we're going to start with angle A, B, or angle C. Okay. So let's start with angle A. So angle A. What kind of relationship do we know with angle A? Well, if we use sine of angle A, what is sine of angle A? It's opposite over hypotenuse. So we know that sine of angle A equals h over b. We also know that sine B, right? Sine B is equal to what? H over A. Okay? And so, excuse me, how can we use those to help us? Well, we're going to solve both equations for h. Okay, so if we solve both equations for h, what do we get? We get h equals b sine A, and we also get h equals a sine B. Well, what does that tell us? Well, obviously if h is equal to both of those things, then we know that what? Both of these are equal, right? So that tells us what? That b sine A is equal to a sine B. Well, this comes from, if you remember a proportion or an equality of fractions, we know that this is equivalent to what? Well, if we divide both sides by A and divide both sides by B, we get sine A over A is equal to sine B over B, which is the result we're looking for. Okay, now we can compare the other relationships as well. Okay, because what I can do is I can draw another altitude from here across to B and use those two right triangles to get similar, to get another set of equalities that relates C with C. So I'm not going to do that, but again, I could draw an altitude from B over to B, or I can draw an altitude from A over to A, and I can use the same similar argument that I just set up with involving C, right? And one of the other two. But once I have the other equation or equality with C, then I'm done. So I'm not going to show you that to you, but once I have the other one, then I know that sine A over A is equal to sine B over B, which is equal to sine C over C. And this is what we call the law of sines. Okay? And this is what we're going to use to solve situations that we get when we have either one of these or any one of these three situations. Okay. Have a great day.